Today on How It's Made. Industrial wire ropes. We'll wire you in. Living walls. Perfect for your living room. Large format cameras for that close-up. And gemstones, making rock bling. But first, industrial machines often have heavy loads to lift or pull, whether it's a dragline excavator working in an open pit mine, an oil drilling rig, a construction crane or farm machinery. The weight borne is by ultra-strong wire ropes. Cables to you and me. Industrial wire ropes typically range from 2 to 13 centimeters in diameter. Besides machinery applications, they also serve as support cables for large static structures, such as bridges or stadium roofs. Manufacturing a wire rope begins with steel wire that's anywhere from 0.6 to 8 millimeters in diameter. The first step is to wind several of these wires together into a strand. How many wires per strand depends on the job the rope will perform, because different applications require different degrees of flexibility and strength. Each wire is spooled onto a steel bobbin and loaded onto a stranding machine, which is essentially a giant winder. There can be as many as 64 wires in a strand, although the typical range is between 19 and 36. The twisting wires converge in a die, which forms them to the required diameter. Lubrication is critical, and not merely to help the wires move smoothly through the die. It also penetrates within to allow slight movement between the wires. This increases their lifespan and prevents the strand from seizing. The strands exit the machine saturated in lubricant. A large rubber band skims the excess off the surface. The strand now travels through a row of straighteners. These heavy rollers apply vertical pressure, effectively erasing the wire's memory of being spooled on a bobbin prior to stranding. This prevents the wires from unraveling. This cross-section shows all the wires inside the finished strand. The clothes peg gives you a sense of its size. Wire strands are typically used as structural support cables. To make wire ropes used in machinery and for heavy lifting, they take several of these wire strands and wind them together on a far bigger and stronger machine called a closer. They make this particular rope from 6 wire strands. Before the strands converge in the die, rollers pre-shape them into a corkscrew-like form. The strands then enter the die, twisting together over a core, which is itself a small steel wire rope. A core at the center of the cable provides additional strength. This cable's finished diameter is 90 millimeters. However, there are always small variations here and there. So now 4 calibration rollers, 2 compressing vertically, 2 horizontally, correct the cable to the right diameter all along its length. The finished cable winds onto a big steel reel, ready for shipping. The factory tests random samples in its quality control lab. There, a machine measures the tensile strength, how much pulling force the cable can withstand. The machine pulls the cable at both ends until it snaps. For this mega cable, the breaking point was 94 tons. For certain demanding applications such as mining, wire ropes are double-coated in plastic to protect against wear and tear. To prepare the plastic, the factory mixes a recipe of clear and coloured plastic pellets. An extrusion machine heats the pellets until they liquefy, then forces the molten plastic through a die, coating the rope as it passes through. As the rope exits the extrusion machine, it passes through water, which cools and hardens the hot plastic. The plastic not only forms a jacket on the rope's surface, it also provides cushioning when the strands inside rub against each other in use. By reducing wear and tear on the steel both internally and externally, plastic coating can extend the life of a rope by up to 50%. A cable's internal construction determines its strength and flexibility. A structural one needs to be strong, immobile and taut, so it's a single strand made of large wires, whereas a moving rope in large machinery contains many strands made of smaller wires. A living wall was always going to struggle to live up to its name, but these green screens serve many purposes, such as hiding an eyesore or shielding an area for privacy. Some are installed in the ground, while others are mounted on building facades and have integrated irrigation systems. Living walls are modular systems. Each module contains fully grown plants, so upon installation, the green screen effect is immediate. These plants are Heterohelix verna, otherwise known as a variety of ivy that's highly resistant to cold and drought. In the greenhouse, cuttings are taken from the mother plants. Foliage is then cut off and the leaves separated, leaving each with a small stem. They then plant the cuttings, 5 leaves to a pot. The soil is a secret recipe of organic and non-organic materials and feed. Over the next month to 6 weeks, each stem develops a good root system. Meanwhile, workers construct a welded frame out of high-strength carbon steel. The metal is galvanized, so it's rust-proof. Once the frame is ready, they take a mat made from biodegradable recycled coconut husks and fold it into a planter box, which fits inside the bottom of the frame. 2 side wires hold the box securely in place. An automated machine fills the box with the same soil mix used for the cuttings. They then plant 13 pots of plants. That's 65 ivies per box. They wrap the longer stems around the uprights of the frame. The frames now move to the greenhouse, where they're connected to an irrigation system. For the next 18 months, the plants grow, and as they do, the horticulturalists keep wrapping the ends around the uprights. This is called training the plants. As the plants thicken, the nursery workers prune them to promote upward growth. The factory produces these green screen modules in 3 heights, ranging from 1 metre to 2.2 metres. After installation, the plants can grow on site to a total height of 4 metres. Each frame, one module of the living wall system, is 1.2 metres wide, making it easily transportable. At shipping time, workers load the screens, tend to a pallet, and truck them to the installation site. Each module of the system installs just like a fence. Workers embed a wooden post on either side of where each screen will go, and dig a trench that's the width and depth of the planter box running in between. They sit the screen in the trench, then with galvanized steel brackets, clip it to the side posts at the top and bottom. They then fill in the gaps with soil. The screens have a 45-year life expectancy, and the leaves remain on them year-round. This variety is used on living walls in Europe and warmer regions. In colder climates, the manufacturer uses a hardier species of ivy, which stays green whatever the weather. I can still see in that bedroom though. Coming up, ugly rocks are transformed into beautiful gemstones. And we'll be focusing on a large compact camera. See you after the break. Around the viewfinder. 19th century technology with some modern refinements. For many serious photographers, the basic concept still clicks. In an age when cameras are miniaturized and digitized, the large format camera might seem to be a relic, but for pros, it's a creative tool. The flexible bellows allow for a wide range of movements for incredible control of the image. Image quality is another attraction. This camera uses big sheet film, 4 by 5 inches and up, generating big negatives that don't need to be enlarged as much during printing, so the image has better resolution. At this factory, they mold many of the camera's parts out of plastic. They inject liquid plastic into molds and the parts quickly solidify. Other parts are made of laser-cut aluminium and stainless steel. The camera maker assembles the base first, attaching rails that slide back and forth for focusing. The next parts allow for swing and shift action, movements that come in handy when composing a shot. He attaches the camera's molded plastic body to the swing and shift assembly. Next, he assembles the front part of the camera, which holds the lens and shutter. It has a swing and tilt mechanism for changing a shot's depth of field. He slides the lens holder into place and secures it. It can be raised and lowered when composing the shot. He inserts spirit levels into slots in the front and rear sections of the camera. These levels will be used to check the angle of the shot. Moving now to the focusing screen. It's made of ground acrylic to diffuse light. He protects the acrylic from scratches with a glass plate and secures the assembly with stainless steel clips. He snaps the completed focusing screen to the body of the camera, where it can be easily switched from portrait to landscape. He tests the focus mechanism and confirms it's operational. He now folds and glues fabric in an accordion configuration to create expanding bellows. These will link the front and rear parts of the camera. He applies double-sided tape around the inner lip of the folded bellows. He sticks more double-sided tape onto a plastic frame and peels away the tape backing in strategic locations. He inserts the frame into the bellows and aligns it with the tapered inner border. He then completely peels off the tape backing and presses the frame to the bellows' taped rim. This frame adds strength to the bellows. Using more double-sided tape and adhesive, he secures the bellows accordion to a larger fabric bag. Next, he glues plastic flanges to each end of the bellows. The flanges attach the bellows to the front and rear sections of the camera. There are two kinds of bellows. The one with the bag attached is usually used with a lens of short focal length. An accordion without the bag has a much longer range of extension to accommodate a bigger lens. He now connects the back of the camera to the front with the bellows. They're a flexible link between the two. By expanding or retracting the bellows, the photographer can adjust the distance between the lens and the film to focus the shot. Finally, he attaches the lens to the front of the camera. It's now ready for a film test. He loads the film into the holder. Normally this is done in complete darkness to prevent exposure to the light, but he's left the lights on for our camera. The film slides into the holder at the back. And while film still rules in large format photography, there are now digital camera backs for those photographers who want instant results with the traditional focus movements of the bellows camera. So, smile, cheese, watch the birdie. Whichever, it's all just a matter of focus. Man has used gemstones since ancient times. Genuine gemstones come from nature, minerals, rocks, or even certain organic materials, shaped, cut and polished to bring out their colours and brilliance. The rarest ones are classified as precious gems, the others as semi-precious. This semi-precious stone is called blue john. It's a rare variety of the mineral fluorite, also known as fluorspar. While common fluorspar is cream or white, blue john also has magnificent bands of purple, blue and yellow. There's only one place in the world where blue john is found, and that's in the village of Castleton, Derbyshire, in England's Peak District. The stones come from caverns deep underground. The miners don't use explosives because the stone is quite soft and brittle in its natural state, and blasting would simply shatter it. Instead, they use drills to carefully dislodge pieces of blue john from the rock wall. They carry the blue john to the surface, to the mine's workshop, where stone processors manually wash off the clay. The stone is wet due to having been underground for some 240 million years. So they put it in an oven at a low heat. When the stone comes out of the oven a couple of weeks later, all the moisture has evaporated. The dry stone, however, is still brittle, so they submerge it in a bowl of liquid resin, then place the bowl into a vacuum oven at 80 degrees Celsius. This process draws out all the air and forces the resin deep into the stone's pores. The stone then goes into another oven at 50 degrees Celsius for about 12 hours. This hardens the resin, stabilizing the stone so it can be worked without crumbling. To create large items, such as goblets and bowls, they turn the stone on a lathe. To avoid fracturing it, they must work the blue john slowly and with diamond-tipped tools. Diamond, being exceptionally hard, cuts with less force and less stress. To supply jewellery makers, the mine workshop saws stones into slices using a diamond-edge saw. At the jewellery workshop, a gemologist examines the slices on a light box to highlight the colouring and any flaws. This helps determine which parts of the slice will yield the most striking gemstones. Meanwhile, a silversmith crafts the piece of jewellery, in this case a sterling silver ring, ready for the blue john gemstone. She bends then solders together the ends of the ring's shank, the part that encircles the finger. After grinding the solder seam flat, she fuses the top of the ring, called the setting, onto the shank. She then polishes the ring and passes it to the gemologist, who takes a slice of blue john and with a diamond-edged lapidary saw cuts out the gemstone shape, making it slightly larger than the setting. Next, she glues on a backing cut from mother of pearl. Just like the light on which they examine the blue john slices, this mother of pearl backing highlights the colours in the stone. Now, using a diamond grit grinding wheel, she shapes the stone to fit perfectly in the setting. She applies glue to the setting and fits the gemstone snugly inside. Once the glue dries, she uses a diamond grit sanding belt to smooth down the edges, gradually transforming the rough oval into a sleek dome. This gem shape is known as a cabochon. Finally, she polishes the entire ring surface until the silver and the richly hued blue john glisten. Whether it's one or several, the shape funky or traditional, a gemstone sure makes a piece of jewellery rock. So, to wind down, we've shown you the ropes of industrial wire cables. And hopefully, we've also planted in your mind's eye living walls to help bring any room alive. Please, put that in your family album, because now you know how it's made.